Hi, welcome to another video on my Raspberry Pi with some electronics. Last time I made the transistor circuit and I covered it with an LED and an op-amp, which you can see here. Added a fischertechnik motor with a propeller and the potmeter. And I was wondering whether this all was necessary to get it running. In the end I had, because this is a pulse width modulation controlled motor, and in the software that I wrote 2 episodes ago with pulse width modulation, that is going through the op-amp and then it should run, which it didn't. However, to get enough power over the motor, I'm using the 5 volts from the Raspberry Pi, lead it through the op-amp and then connect it to the output of the op-amp, and then it runs. And I will show you once again. However, someone told me that is the op-amp actually not ruined by the 5 volts, and is it possible to run the motor without pulse width modulation? Well, for that a simple test is done. This is the 5 volts. This is the plus for the motor. And that wire should be nice to cooperate. Let me put it here. And I turn again on the potmeter. So it does run without pulse width modulation, but it is 1 speed only. So now if I put it all back, let's see what happens then. Can I indeed only then regulate the voltage or the speed of the motor? So now it runs via the op-amp again. Let's try again. It runs slowly. It starts fast. And now it runs not as fast. So let me put it again outside the potmeter, outside the op-amp, and try again. If I can regulate the speed nicely. So yes, it is possible. It runs quite slowly and without pulse width modulation. So it is not strictly necessary, and maybe this way it is saving the op amp as well, but the data from the op amp says it should be able to handle 5 volts, so that is not a problem. Is it nicer to do with an op amp? Well, it amplifies the signal, but it by far not enough to drive the motor. The op amp, that is the signal from the pulse width modulation. So it needs the addition of the 5 volts to run. That said, some new adventures with another motor are in stock. With the motor and propeller taken out of the op amp circuit, the question is if the op amp actually does do an amplification. So to test that, I connected the output of the op amp to this LED, and I hope that it will shine brighter than this LED, which is between the transistor and the op amp. So let's start the program and dim the light a little, and I don't see a positive reaction of the LED, so let me just reverse the LED, and yes, that does work. Well, it did for a moment. Let me put it that way. So I find this kind of strange. Let me reverse it again. Ah, now that's remarkable. Now it runs with this in the plus. It runs, while I expected it to run the exact opposite way, like this. And obviously this doesn't run. So the question is, with this connected to the output of the op amp, is it actually doing anything? Is the voltage over the op amp high enough to do anything at all? And that is a very nice question, and somehow I think the answer should be no, because it looks like right now that the op amp isn't even powered. So I will use a little branch here at this point, and the opposite side is going in the plus of the op amp. So now I'm sure that it is connected. It is powered. And let me turn the op amp higher. So right now we can see that the motor is not connected via the op amp, but it is but this LED is also connected through the voltage of the op amp of the potmeter. And then you can see that it all runs. Let me see if it has the exact same effect when I turn it slowly back. I hope you can see that the light is very slowly dimming. The propeller is running slowly and the LED is dimmed for a great deal, with only just. And another thing is that I have to put the potmeter almost to its maximum. So in conclusion, now the op amp is powered, still powered through the op amp, through the potmeter. The motor runs without pulse width modulation. So while I thought that I need a pulse width modulation to run the motor, that is not true. But this is a nice circuit anyway. So let's see what we can do further. The next idea is to extend the circuit with an RC bit. So here I have the same resistor as I've used in this part, and I can simply add it right here. And here I have a 6800 microfarad capacitor, and that I want to add from here to the base of the transistor I've put here. And I think I should better put the resistor here. Then I have some space for the capacitor, which should be in the same line, which hopefully connects with, and it goes out already. So I need to do this carefully. And then I need another jump wire. Let me take this one to connect it all. to connect the capacitor to the base, but I'm worried about this connection. Will this work? So only one way to find out: turning up the potmeter. So this still works. Does this work, or is that a problem with the wire? I wouldn't be surprised if this has to be pushed in further. Let me short circuit the capacitor a bit. It doesn't do a thing. And this is remarkable if you listen carefully. It looks like that this pressing has an influence on the motor, which can hardly be. But this red LED doesn't function. I'll remove it and replace it. So and that's a loose potmeter, and let's see, this should be working. It's hard to see. No, neither way response. So this is probably a failure here from the capacitor. I'll just put it in like this, so it is anyway connected, and I probably have to use a different capacitor. I'll use a 2200 microfarad. Let's see if that connects better. So then this one goes in here, and this one should go in here. And yet again, I'm just experimenting. And it's too bad when one of the wires is not cooperating. So this should work. Unfortunately it isn't. So I need to start measuring some voltages. So with this measuring probe I connect the red one to the plus. I connect the black one to this resistor, and you see that the multimeter nicely responds. So then I do the same here for this jump wire, and it goes all the way. I put the multimeter higher to 12 volts. And it says 11 volts. So this means that here on the transistor it says 7 volts, and here on this part it says 12 volts. So there should be a lot of voltage on this LED, which indicates that I might need to replace this one or put it the other way. Let's see if that works out. No. I'm taking another LED and it should be put like this. Now I'm taking care of the wires. This is not responding properly. What if I put them the other way around? Neither. So I'm measuring again. Let me put it this. So I'm measuring right here, and you see there is enough voltage over it. So remains the question, why doesn't that let that LED burn? Let me slow everything down. There should still be enough voltage over see, there's still enough voltage. And how much is there over here? 12 volts. And that's interesting. How much is there on this side of the transistor and on this side on the transistor? That is interesting to know. Nothing. Now there is nothing. So this is interesting. Here there is, and here there isn't. Let me turn it up. Here there is, and here there isn't. So this is an interesting find out, that despite that the voltage is correct, an LED doesn't burn. Which leads to the question, if I replace the LED with the motor, would that work? Now I think I'll let that experiment for the next time. So with these few experiments, surprised with the pulse width modulation, adding of an LED and adding of a transistor with enough voltage. Nice for now. So enough to be continued. Thank you for watching.